Good morning.
All right, can you guys get your presentation set up?
Yeah, so I would share my screen for the presentation. Is that right?
Yes, that sounds good.
Okay.
Can we get the team name, please?
Golden House.
Okay.
Golden House.
All right. So we're gonna be strict about time, and we're gonna cut you off at 5 minutes, as an FYI.
Yeah, that's fine.
Yep.
And Fiona will message you with time marks about how much you have left.
Okay, that sounds great. So I guess we'll wait for your cue for us to start, or how would this go about?
Yeah, I'll give you the time of when to start.
Okay, great, thanks.
All right. Whenever you're ready, take it away.
Okay. So good morning, everyone. I'm Daryl.
I'm Ren.
I'm Ren.
Yeah, and I'm Brian.
And we are Team Golden House. And today we'll be tackling the Sterlite Power Challenge. So for this challenge, we are supposed to identify, collect, and analyze behavior. We're then supposed to send all this information back to the supervisor on a real-time basis. And lastly, provide a technology-based solution that's both cost-competitive and scalable. So to tackle this problem, we actually came up with this overall concept, which is to capture, detect, and then report. So for the capturing, we're making use of body cameras and wide-angle cameras to obtain footage. We'll then be applying computer vision to detect unsafe actions and unsafe conditions on the flight. And lastly, we'll relay this critical information back to supervisors off-site and workers via a lighting system. So in any scenario where an unsafe action is being detected, all activities will be immediately halted. So this concept actually comes together in our out-of-the-box solution, the Golden Box. So we have some experience in the military. We actually leverage that knowledge when we came up with this solution, which is why the box, our solution, the box, is actually quite portable, durable, and scalable. So all the required equipment is packed neatly into the box, and there's minimal configuration required by the on-site workers. This allows for easy adoption and making it very scalable. So these are the items that are actually present in the box, which will be elaborated later on.
So this is how our idea works. So first, each of the workers will be equipped with a body camera vest, and on the Golden Box, there will also be a wide-angle surveillance camera. So these two cameras will be able to capture the workers' surroundings in a first-person and third-person's perspective, and send the information through a router to the laptop. The laptop receiving the image will then process them using artificial intelligence, using neural networks to be able to determine if the workers are currently in an unsafe environment. It will then send status updates back to the body camera, which will have a LED that will reflect the status of the workers. So what we adopted here is a traffic light system, with red being unsafe and green being safe. The laptop will also send the worker's status through the radio to the supervisor, who may or may not be at the work site. The supervisor can then see the worker's status as well as resolve any unsafe situations.
Within our Golden Box, we have two different types of cameras, the first of which is the wide-angle camera. This wide-angle camera is used mainly to detect the unsafe conditions, and it is weatherproof. So we are able to obtain a very macro view of the entire work site. And using computer vision, this camera is able to detect some unsafe conditions, such as the improper laying of cables. The other camera that we are using is the body camera, which the workers will wear on their bodies. And this is mainly used to detect the unsafe actions. This camera is a LiDAR camera, which is a technology used by the new iPhone 12. And this allows us to have a 3D imaging of the hands and the different components. And therefore, using the computer vision analysis, we are able to determine whether different safety protocols are being adhered to.
So there are two main communication modes used in the Golden Box. In the local work site, we are using wireless local area network. This is chosen due to the speed of data transmission. Between the remote supervisor and the Golden Box, we have chosen a VHF radio. This is more suitable given the remote working conditions that the workers will be at the site. This is because VHF radio is much more reliable over long ranges. For the implementation of the Golden Box, we will first begin by purchasing the equipment and collecting the data. The first few months would be primarily to collect the data and to train our machine learning model. The next steps would be for initial deployment and to collect further data. And finally, with more data, we can retrain our model to perfection and deploy our model finally. As you can see, we have prepared a sample cost sheet for the Golden Box. These are average estimates for the individual cost prices as you can see, the Golden Box is by no means expensive, coming in at slightly over $3,000, and it is extremely cost competitive. And with that, this concludes our presentation for the Golden Box, and we would like to thank you for listening to us.
Okay. Shall we jump in, Andrea?
Sure. So we have 5 minutes of question and answer right now.
Right. So could we just go back to the cost slide? Just wanted to understand the $3,000 a bit better. The
Oh,
components.
yeah, sure. I believe this is it.
Yes, this
Yep.
one. So this is each box comes with is costing at roughly 3,000, right?
Yep.
And in your solution, you envision one of these boxes per location, per site?
Yes, that is correct.
Yeah.
But I guess one thing to add on is that we did not, these are simply the cost of purchasing the hardware equipment. We did not factor in the cost of hiring a data scientist engineer, for example, because there would be costs associated with training a machine learning model and stuff like that as well. So, yeah.
Got it. So the first reaction there is that, see, we have anywhere from what, 50 to 100 sites per project. Maybe Vivek, Karthik, keep me honest here. If we multiply this by 100, I think that is slightly prohibitive on the costing side. Any thoughts you gave around maybe looking at some cost reduction from this package, or do you think this is the absolutely minimum required to meet the purpose of the solution?
I think what we want to achieve with this is a box that's very mobile, so it can follow the maintenance crew around. So it doesn't have to stay at the power station. It can move to the next one when they're performing maintenance there. So perhaps to cover like 100 stations, maybe just need like 1 or 5 of these boxes on 5 maintenance teams that are running around to fix the individual sites.
I think the main idea is to have 1 box per maintenance team to follow them around, not 1 for every site. Yeah.
And so one is the data capture, right, which goes into your algorithm, and then the machine learning learns from it and things like that. What's the other end of it? How do you envision the other side of the input that comes from this? I mean, so you're kind of analyzing what's happening on the ground, on the site. There has to be a feedback loop, right, that helps close whatever the findings are. Any thoughts on the next steps from there?
So after analyzing the results, there's a lighting system. So the lighting system will be reflected on the worker's vest directly. So that is the red, amber, and green LED. So that the workers will get an update straight away. Whereas for the supervisor will know whether there's actually anything unsafe. And if, for example, if it's red, he will probably be alerted to it, and then he can perhaps, through other means of communications or through the VHF radio, call someone on the ground to find out more about the situation. So the feedback will come in 2 forms: 1 through the LED light straight away, and 2 through the supervisor if he wants to find out more about the situation. Yeah.
But in either case, this would be like a real-time feedback loop. Right? This is like instant.
Yeah.
Yep,
Once-
exactly. So
Really?
actually, yeah, this concept is sort of borrowed from a machine shop floor. So we've worked in manufacturing factories before, and in the middle, in a smart factory, for example, there will be a television in the middle of the shop floor where you can see all the status of all the machines. So it's quite a similar concept, and you're absolutely right that it's a real-time feedback loop.
And we also understand that when we are using this golden box, we are also maybe laying power cables in like mountainous areas or very remote locations. So that's why we use radio as our main form of communication, because it is the most like reliable form of communications. You don't have to rely on any cell towers or anything, and it can withstand the harsh conditions even if you are in like, a remote area.
Understood. Vivek, Karthik, I'm done.
I'm good as well, Manya. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you so much.
Yeah, sorry, I have one question. I was on mute actually.
Okay.
So with this one golden box, you are providing 10 kits. That means only 10 workers can be connected with this golden kit.
So that is what we're estimating, like the number of cameras that are
Yeah, but
expecting that we need. Yeah.
Can I increase the number up to 25? 25
Of
one
course.
golden box?
Yeah.
Okay.
Yes. Yeah. So to scale it, we just simply need to change two things. First, we just need to purchase more body camera kits, and if the capacity gets very large, we would then need possibly a more powerful router as well. But that can be changed very quickly.
Right. Thank you.
Great. Thank you so much. Hope you had a good experience presenting. And yeah, we're going to meet the next team so they can get ready for the presentation.
Thank you.
All right. Thank
Thank you
you.
for
Thank you
having
so
us.
much.
Yeah, thanks for having us.
Thanks, everyone.
Bye.
Bye.
Bye.